In a few words, I could describe my job as I'm Mr. Wolf, I solve problems, if you are a Pulp Fiction movie fan. Solving problems about space structures is my main task, and I can tell you that there are always a lot of things to pay attention at. We have to work hard to convince people, but also ourselves, that the satellite and space systems we are designing won't become a giant maracas in space, and they won't fall on our heads. It's always very interesting and challenging because each space system has its own objectives and requirements. And I can say that indeed we build quite custom-made and expensive flight things, and that the failure is not an option. We have to find a good compromise between strength, cost, and availability of materials. And this is nowadays it could be a real problem. As I said, each system has its own characteristics. We have to produce predictions and calculation to be sure that it is compliant, that it can survive all the kind of environments that you can find both on Earth and in space. And I'm sure you know that the life of each space system has several phases. Of course, launch and commissioning phase together with the mission itself are the most relevant, most important, but also we have to consider transportation, handling, testing, and also the commissioning, because we don't want to have the space junk growing. So each phase has its own loads, and we have to be sure that the structure itself is okay for all of them. I'm in charge of structural verification both from a mathematical and a physical point of view for all the parts of the space system. In addition to that, I have to retrieve loads for the onboard units and components to be sure that they can survive the launch. For each space system that we design, I have to build a mathematical model, basically a finite element model, that I can use to perform some simulations and calculation using structural softwares. Together with the verification by analysis, time to time I have to follow the test campaigns related with vibrations. But why vibrations? Well, you know that launchers are very powerful machines and they are extremely noisy. During a ride to the orbit, each space system is subjected to several loads and accelerations, and I have to check that each component and the satellite itself will be safe during the launch. The launch itself, as said, is the most important part of the mission, as a failure during it could be catastrophic, not only for the space system or for the satellite, but also for the other passengers and or astronauts that are on board. Next to structural analysis, I cooperate with other designers and engineers to optimize the functional parts in order to get always the best from each single gram of matter that we launch. You know that launching stuff in space is quite expensive, and if you can save some mass improving the design, you will get a net gain on the mission cost. Nowadays, we have additive manufacturing and topological optimization that are helping a lot in defining the future of space explorations. And in order to be able to process a very large amount of data that we get from each test campaign, I'm also in charge of developing methods and routines for a fast and reliable post-processing of all those data. I really like to think about new solutions that can help solving issues from different perspectives. Sometimes in space, you could have issues that are not common on Earth because of the extreme environment or other reasons. Then you have to find common solutions for uncommon problems. I like to think about the design and improve them according to the customer's needs. Sometimes it's very hard because of the constraints you have in terms of mass, size, or costs, and so on. But when you find the solution or a good way for doing or making something, you feel like a child that has just completed a puzzle. From a mathematical point of view, it's always a pleasure to prove that indeed 2 + 2 = 4, especially when you create a big mathematical model from scratch, and during tests you verify that indeed your predictions were right. It's something like proving the existence of other planets, simply calculating their orbits and knowing where to point your telescope to. During my years at university and in my career, I had the opportunity to experience several fields, from aerodynamics to space propulsion and structures. Working in all those different fields gives you the possibility of expanding your knowledge and to react properly to each input you get. For my dissertation at university, for example, I spent 6 months in Siberia studying and comparing Eastern and Western methods for designing space engines. And I studied the possibility to replace the current third and fourth stage of the Vega launcher with a liquid rocket engine. And that was designed using Russian methodology. It has been very interesting, but also very challenging, because all the handbooks and textbooks were written in Russian, so I had to learn Russian to be able to understand them. Talking about other experience, in the first years of my working career, I was employed as an offshore field engineer on an oil and gas construction vessel. As you can imagine, it was completely different from what I do now. But working every day with experienced workers like welders or pipefitters was very helpful for me in order to move from theory, that is what we learn at university, to a more practical engineering approach. What I've learned from those experiences is that we don't have problems, we have only solutions. And the solution has to be reliable and safe for everybody. All those experiences were a great training for me for being able to find solutions out of the box in case something happens or goes wrong. And I can assure that it's always the case during a vibration test campaign, for example. The more you have seen and you have experienced, the best is for your working life, but also for your mental health. I would have given myself a few simple advices. First of all, be curious. Be always willing to learn from others as much as you can. Don't be afraid of asking questions, and start to work in the space sector as soon as possible. We know that the space sector is evolving quickly and new technologies are helping in solving issues. I would have liked to experience earlier with other new technologies that now are commonly available, as for example 3D printing or electronic prototyping. I've already had different experiences in other sectors that are always also useful in the space sector, but maybe having some other experience about electronics would have helped a lot for my career, in boosting my career now.